Good morning, everyone. I want to give you a very warm welcome to all of you that joined today. And I'm really looking forward to getting to know all of you during today's event. Today, we are opening the 2022 InnoWise Scale pitching series. And we have a common topic that will drive us over the next 5 events in the next days, Road to 2030. We want to envision more circular futures around water cycle perspectives. And this will be today, we will be having a key question that is about how recycled water can be a solution for water scarcity. My name is Patricia Carbonet. I'm actually working in Revolve, leading the team in Barcelona, and we encourage and promote cultures of sustainability as a communication agency. Other Revolve members of the team are behind the scenes today, Marta, Martina, and Cora. They've been also involved in putting together today's event, of course, in collaboration and supporting the EIT communities that they are actually bringing this program together. So today, I want to give a special thanks as well to Blanca Chocarro, project manager from the EIT Manufacturing, which is the reason why we are here today. Just a quick reminder, we are right now live on YouTube, on social media. So my colleagues will be addressing comments, questions, and any question that you might have will be here today. We will be taking it, and we will be also presenting the solutions providers who took part of this program, which are the innovators in the water sector. We also have an amazing team of jury members that will be evaluating the pitch, and also great experts that will be talking about water insights. So stay with us for the next 2 hours because we will be bringing very valuable input for all of you working in this sector or aware of the challenges that we face over the next years. So I would like to give the floor to Blanca Chocarro without more hesitation.
Thank you very much. Let me share my screen so I can explain a bit better how the program works. Okay, I think it's there, but I cannot open it. 1 second. Sorry, but I cannot see my screen. Yeah, it's there. No, I cannot open it. Maybe if it's better if you share my screen, I think, because I cannot put full screen.
Marta Castillo, Revolve joined.
Oh, I can try again, but I don't know. Okay, so full screen mode. Thank you very much, and sorry for this technical issue. I'm Blanca Chocarro, and today I would like to talk to you about not only this session that we have today, that it's the first of a series of pitching sessions, part of the InnoWise Scale, but also the framework where this comes from, the European project finding innovative solutions for water scarcity in Southern Europe. So, next slide. This, to give you a bit of context, this project is funded by the EIT, and we are developing as a cross-kit project by the Knowledge and Innovation Communities, the KICs. The EIT, next slide, stands for the European Institute of Innovation and Technology. Next slide. And it's Europe's largest innovation community. And we work what we call through the triangle of knowledge. So we have the EIT supports first activities on education, but also give support to innovation, so facilitating the market access to innovation, scaling up solutions, and then also on the business creation side, so supporting startups, scale-ups, and SMEs. And the EIT does so, next slide, through the knowledge and innovation communities. Next slide. And I am, for example, part of EIT Manufacturing, but also this project is composed by other KICs. So it's led by EIT Food, and also EIT Digital and EIT Climate are part of it. In the case of EIT Manufacturing, we have over 80 partners and from 18 countries, so from EU and EU associated countries. Half of them come from industry. Here you can recognize for sure large corporation names, but also startups, SMEs, and scale-ups. And half of them come from academia or research and technology organizations. So next slide. As for this project, the EIT water scarcity community, next slide, is, as I said, for KICs, but also some of our partners are involved. So also we have Athena from Greece, the Azul from Spain, and the Technology University of Delft. So we have a pan-European and multidisciplinary network working on water scarcity. But what about this program? And this is part of InnoWise Scale, an activity that we have as part of the water scarcity community. Next slide. Next slide, and two more. And the program started some months ago in May, when we selected the startups and scale-ups, some of them here today, to present their solutions. And through the first half of the program, we were supporting them with tailored mentoring, but also with market-oriented trainings and with a lot of visibility. And in this second half of the program, this past few months, we had an open innovation action. So we have 5 problem holders, 5 companies and water utilities with specific challenges on water scarcity. And then these solution providers, these startups, were offering solution of them. So we did a series of networking activities and matchmaking. So at the end, each company selected 7, 8 startups to work with them specifically. So in the next slide, you can see that today is the first speech, but next slide. But we have other pitches, previous one. So we encourage you to register. We had other companies and water utilities in this week and next one. So as for today, we will giving this startup a first and second prize. Our jury will be awarding them based on innovation and impact. But then we also have a special prize that is a challenge that so will be awarded by ENCE, our corporation. It's a pulp and energy company based in Spain, and the solution provider with a better solution that fits their needs will be awarded a voucher of 30,000 for demo testing at the industry facilities of ENCE. So in the next slide, we have actually a wider program. So in this water scarcity community, we are not only working with the startups, but also we have enrolled over 45 experts that they have delivered 2 publications. And during this year, they have been doing seminar, our body on knowledge, and then working in this triangle of knowledge that I have mentioning earlier. We have the water academies from the educational side. And this year we had 3 on-site workshops, and by the end of the year, we will have a long online course available on Future Learn on water scarcity, but more specifically, 3 modules on water reuse in agriculture, water efficiency in the manufacturing industries, and nature-based solutions. So in the next slide, you can meet all of us that we are involved in this project. So it's not only me, but also from the other KICs and from the other partners. And so if in case you have any doubts, you can contact me or any of us or our coordination, Carmen Galindo from EIT Food. So that's all, and thank you very much for your attention.
Thank you so much, Blanca. That was a great overview. I think this program, it's very important. And I think in this time of life that we are moment in which water scarcity is crucial. And we just finished 2 weeks of negotiations in the COP 27 in Egypt, we wanted to bring this as a follow-up to these discussions, the dialogues that happen there on a higher level, let's say on the policy-making level. But these actually bring us to the tangible solutions. These bring us to the actual work that the companies around Europe and in the Mediterranean are trying to advance. And in order for them to really, keep advancing and improving and shaping this situation that we face, we need, of course, finance support, we need political support, we need incentives and regulations that actually are behind all of them. So this is an opportunity for us to put them all together, to try to discover more what is the state of the art in the water sector, and actually look at the future and how we want to shape it. So I think this is very important, and I think one of the main points of this program is also the matchmaking idea, in which the problem holder, which in this case it's ENCE, that we will be presenting in a few minutes, actually has been able to work as well together with the solutions providers, which you will also meet today. So we have a very exciting agenda of 2 hours, as I said, in which we discover these solutions. And we have a keynote presentation from Silvia Cortiñas. She is the Environment and Business Development representative at ENCE, and also the problem holder of the InnoWise Scale EIT Manufacturing pitch session. Once this groundwork is set, the innovators will pitch their solutions to address the challenges of the problem holder. And then the jury will evaluate and we make some questions live in order to then make a final decision towards the end of the event in the award ceremony. In between this award ceremony, we will have a roundtable discussion with David Smith from Water, Environment and Business for Development, Hassan Abuelta from Middle East Water Forum, and this session will be moderated by journalist Abi Devi. She's a journalist at the H2O Global News. So we will be having a very interesting discussion about how recycling water can be one of the potential solutions. So if Silvia is ready in the back end, maybe she can give us a few words about the... Hello, Silvia, here you are. So she can give us a quick presentation.
Hello.
Nice to have you here. Thank you so much for joining and for being part of this program. So the floor is yours and feel free to present.
Oh, thank you very much. We solve our technical problems. Right now we are really connected. And first of all, I enjoy this experience. Interesting opportunity for our company to understand or to contact with these different startups, different points of view, and all of them have to be something new for our company. Very interesting, this program, and we would like to share with you all the challenges we are faced on that, and how these startups behave or share their knowledge and their technologies with us to try to solve our challenges. I going to share a small presentation. I hope is it possible for you to see? Okay. Okay. Perfect. We began this challenge or this experience sharing with all the startups ENCE water challenges. We are a company for pulp production, and we develop a different experience and different projects to reduce our environmental impact. This point are a very important cue for our company because it's so important for us to keep the sustainability of our operation and activities. And nowadays, one of our challenges are related with the water consumption. Why this challenge is the important necessity for us in the future is most of the time climate change and the sustainability of our industrial operations. The situation, it's our internal projects let us to reduce our water consumption from a position to 37 cubic meters per ton of pulp produced. And nowadays we are about 25 cubic meters per ton of pulp. But really, we would like, or we need, to reduce our water consumption in even to get a CLD zero effluent. It's our target, it's our project, and it's the aim that we would like to get. For this reason, we are involved in this experience with the InnoWise platform, and we would like to get better results in the next future. What are the keys to get a success in the phase of this challenge? Our technologies, or our way of manage this challenge is first of all benchmark with the pulp sector, trying to look and trying to get the best technologies all our mates or our competitors are implemented in their industries. And we would like as well to look for different water efficiency technologies. It's very important to understand what kind of technologies are really on the world are developing, and even it's not perfect for our sector, maybe it's possible to adapt or to introduce in our industry. And one of the keys of this success is to reuse water. Most of the water we would like to reuse are condensates from the steam we generate in our process, because some of the part of the tree we transform in energy and steam, and it belongs to the tree and to the raw natural materials, for us are very, very important as a resource for our industrial projects. And the last key for the success have got until now is the partial reuse of effluents that we have treated to get the enough quality for the water to reuse in other parts of the process. But when we develop these four technologies, or these four ways of getting better technology, we haven't got until.
Just a
Yes.
second. Yes, sorry to interrupt you. It's just that the PowerPoint presentation is not moving, so we cannot see the slides that you are talking about. So if you can maybe
Sorry.
click on this just to follow what you are presenting.
Yeah. Oh, thank you. Thank you so much.
Sorry.
We would like for the. Okay, we're trying to share again. Okay.
Otherwise, we can try as well. We have the presentation.
Yeah. Thank you. Thank you. We try again. We haven't seen anything, or maybe the first slide.
Only the front page. So.
Okay. Thank you. Yeah. Maybe it's because of the way of the presentation. I'm not sure if you can see right now.
We can see the second slide, but it's
Okay.
not full screen. So we will need to see it full screen and see if it.
Yeah. Okay, I try again. Could you see the second slide?
No.
No. Okay. Maybe Marta can help me and use the presentation to give the information. Oh, thank you. It's Marta sharing or me? Okay.
It's you right now, but we will make the transition then.
Okay.
Ah.
Yeah,
Okay.
it's not good. System. It's true that technical issues are not good
Okay.
for us
Yeah.
today.
No worries. I think we can go ahead with what we have. Right now, I think it's better to continue and listen to what you were saying. So otherwise, we will take a while.
Okay, I can try again.
Yeah, you can try to reshare again the screen.
Yes, I'm doing, but really, I don't get success. I hope. Is it okay right now?
We can see the screen, but you need to make it full screen and write on the slides in case we can see it.
Yeah.
No, it doesn't work for you.
No, maybe it won't work. Yeah, I'm changing the slide,
Okay,
but maybe
we can see the
it's not.
key to success.
Sorry.
We can see one of the slides, but we don't see if you click any other. So I think
Okay.
maybe without full screen,
uh,
you can try to continue the presentation. Maybe by using
okay.
just a normal screen, maybe we can follow what you
And
are
in this
saying.
in this way of showing the presentation, could you see the different slides? Even if I not use the total or the complete screen? No or yes?
No, I think we should continue until
Okay.
we can play the presentation. We will try to.
Okay, we can share without presentation, and I try to reduce my 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 introduction. Okay, okay, without presentation, and I try to show you our targets or our challenge. I have been trying to explain to you how to manage this challenge nowadays in ENCE, and with these options or with these possibilities, we have got good results because right now we are in the low range of water consumption for the pulp sector in the breadth or in the reference of best technologies for the water consumption. The reference for our sector is to be between 20 and 50 cubic meters per ton, and as I say before, as I explained, our target is to be below 20 cubic meters per ton. What are the main difficulties or problems we have on this process? The reuse of water give us the necessity to increase the chemical compounds that we need during the process, along the process, and the same another second problem is that among we are increasing the reusing of this water, the reuse of water. It's necessary for us to upgrading the effluent treatment plant facilities, and the temperature could be the main important problem to get or to get to reuse the amount of water really we need. When or where we would like to go deeply to develop our project in an easy way, we would like to introduce new techniques or technologies to implement in our project. We would like to decentralize water and wastewater treatment technologies to use different technologies in our process. We would like to develop a tertiary technology effluent treatment and color removal. Right now, we are implementing this kind of technologies in Pontevedra Mill, and the results are really good, but we would like to develop in a more important way. We would like to remove non-process elements in the water circuits. It's very important for us to get water reuse technologies to remove specific chemical compounds. And at the same time, we would like to have a real-time control using optical water quality monitoring technology. As I explained that the temperature and energy, it could be a problem for the development of this project, we would like to introduce as well energy consumers technologies and renewable energy production technologies. All of these targets or all of these issues would be a very important change to our management, and really are a good challenge for us in order to get the results we are waiting for. So this is our challenge, and the main targets we showed to the startups, and all of them has working hard to give us or to try to give us solutions for these targets. For my part, it's okay. Sorry for the problem with the presentation. I hope I try to explain to you as much better as I can our challenge.
Thank you so much, Silvia. Sorry for the inconveniences with the presentation, but I think we grasped very clearly the challenges you are really trying to promote to reduce the water consumption. So I think it's the time now to make the transition to hear from the solutions providers what they came up with and how they can really contribute to. So thank you, Silvia, and we will
Thank
see
you.
you in the next round. Thank you. Great. So in this session, we have 4 wonderful jury members that have joined us today. One of them is Tom van de Kerkhoff, sorry for the pronunciation, Stefan Ruiz, Besna Kulin, and Andres Luch. They will be evaluating the pitching competition videos that the startups, companies, they have shared with us. So we will be playing each of the videos, and we will have around 4 minutes to have a short Q&A to address any points that were not addressed in the video or were not clear enough. So I think this is a good opportunity for us to watch them. So if everyone is ready, we would like to start with the first video from Granite, and then we will continue with the Q&A with the jury members.
Hello, I'm Pablo Romero, CEO of Granite, the precision farming platform based in satellite imagery. We live in a world overexploited in resources. For example, the 70% of the water is used in agriculture, and also the 76% of our soil is at risk of desertification, between other problems. That's why we present Granite, to optimize the critical decisions of farmers, technicians, and agronomists so that they can improve their decision making directly into the field, in irrigation, fertilization, between other activities. We generate impact in 3 ways. In an economical path, also optimizing their decision, and by improving the scheduling of their time and task in the fields. Our target market is in cereals and trees. There is the total quantity of hectares in these 2 crops in Spain is around 13 million hectares, and we are already present in Spain and Italy, and looking at Latin American market. Our business model is an annual subscription per hectare, where they can choose a packet according to the resolution imagery that they want to use in our platform. We boost our sales via B2B, while we prepare ourselves by gaining notoriety in B2C. And we do it thanks to assisting to events, and also thanks to our social media like Instagram and LinkedIn. Granite already managed to be in the market with international players without external financing. And we need to stand out that we are experts in processing satellite imagery data. There is a very big opportunity and a very favorable political and technological framework in Europe right now for digitalize the agricultural sector. There are some laws that are helping to digitalize the sector, and also a lot of investment that is coming directly from the European Union. We have a total of 26 paid users. We made a total of 17,000 euros overall in the second semester of the year, and we already negotiate 20,000 euros for the rest of the year. We are a very multidisciplinary and multicultural team, and we are passionate about technology and agriculture. Who support us? Very recognized institutions and public institutions, like the ones that you can see in the slides, as well as we work with some brands that you can see directly in the slides. We would like to finish the year by doing billings of 30,000 euros, so that we can work during the next year in the machine learning and artificial intelligence algorithms created by ourselves. And in 2024, we would like to make the brand international. The need of our problem holder, that is HANS, we can use very high satellite resolution imagery for saving the current cost that they are having, to improve the forest management and improve also the work schedules that they have. So join the satellite innovation in agriculture, join Granite.
Thank you, Pablo. Thank you and welcome, Pablo. I would like to give the floor as well to the jury members.
Thank you very much.
Short Q&A, and thank you so much.
Well, I can start if you want. So congratulations for your presentation. It was very well structured and approach all the questions that we need to evaluate. So congratulations for the organization of your pitch. It's very well done. And I would like to know a bit more about the expertise of the team, because you mentioned with a slide and you mentioned that you have a lot of expertise, but could you go a bit further on this point, please?
Yep, sure. Well, first of all, thank you very much for your work. And we are 4 people in total, 2 founders. We are a telecommunication engineer and informatic engineer. That's why we are working a lot in the processing of the data and the management of the data. And then we receive the help of another informatic engineer who lives in Ferrara, that is Zaki. And the last partner is Mariana, who is an agronomist engineer. And she studied in the University of Córdoba here in Andalusia.
Thank you.
You're welcome.
Thank you, Pablo. If I can continue. I have a question regarding this precision farming system. Is it focused only on agronomic engineering to use, or do you provide tutorials for maybe some farmers that are not familiar with this technology?
The users of the platform can be farmers as well as technicians and agronomists. They can use the platform. We have a YouTube channel where they can see some video tutorials, but they can also ask us directly, like that we give them high support if they really need it. But the good point of this is that our targets are the technicians and the agronomists that already have knowledge on using this type of technology, so that we can process the best as we know the data, so that they can use it and interpret it as they know and as they know their fields, because we don't know their fields, how they behave, but they already know it. So thanks to this information, they can improve their decision making. And another point is the API that maybe I didn't talk in the video. We are focused also in the companies that are already into the sector, for example, using sensors or other type of technologies, and they want also the data that we manage to do, and we can deliver this data thanks to our API. So we are very focused on this data provider system, let's say.
Mm-hmm. And maybe you are ready to implement their input directly from the handling the data themselves, and then you can upgrade maybe some things.
Exactly.
Necessary.
We create insightful maps, let's say, that they can use for their diary activities.
Great, thank you.
Thank you.
Also from my side, a very nice initiative. Working at the start of our food supply chain is where there is still a lot to do. So I would say in any sense, regardless of what the outcome is of this, good luck with the startup. The question I would have is if a client is looking for a solution for improving the fertilization and the irrigation, what would be your competitive advantage compared to a sensor-based company?
First of all, the scalability. Let's say that it is not needed for us to be present in the field to install any device, so that we can give directly information about, let's not say directly fertilization, but how the crop behaves itself in some cases, no? Even sometimes, for example, the technician can apply some products, and thanks to our technology, they know how the crop is going, if it's going well or if it's not going well, thanks to the application of that product. So if I want to give my service to Peru or Chile, I can do it in 5 minutes. I don't need to establish any, let's say, cooperation with a local company, so that they have to install the sensors and then create a network and collect this data. In fact, our mission one of our missions is to find these companies that already use this type of data, so that they can improve their, let's say, values or insights thanks to our data that we process.
Thank you.
Thank you, Tom.
Thank you so much to everyone. Let's continue with the next company, Aqua Q, which we will represent in the video, and then Ula will be answering the questions. Thank you.
Treated wastewater, it's a mental barrier that we will not use it. That is a general case in everywhere. So we have to learn people and show them that treated wastewater can be used for drinking water.
Aqua Q has developed an online monitoring and sampling early warning system for drinking water and water for reuse. A fully automated system that provides preventive information on disturbances such as technical breakdown, infiltration of surface water, chemical or biological contamination, and other changes in water quality that may present a risk in water production and distribution.
Waterworks, they cannot wait for the analyzing result. So with our system, they can know immediately and they can take action. Treated wastewater contains pharmaceutical residues and pathogens. These are the very contagious substances, and it affects the environment. The reuse of water is used today for irrigation or recharging the groundwater. If this contains in that water, so it will affect human beings, the vegetables that they wash, or the farmers that they want to have an irrigation process. So this has to be removed. This is actually two inventions. One is an early warning system for contamination in water in real time. And the second innovation is when there is a contamination, what you will do, you have to remove it.
It's an ozone polishing system, and it's only needed when the water is contaminated. Ozone is nothing new, but the way how you use it. If we use it together with our system AquaTrack, we only need to use the ozone polishing when it's needed. It's saving energy in that way. The Aqua Q water quality analyze and cleaning system has been tested in large scale in a Swedish municipality and can also be used in smaller building complexes, in water plants, or for example the food industry. In India, the company is looking for development partners.
We're looking for a partner with investment who has the capability to manufacture and distribute and market locally.
Every year throughout the world, water and wastewater treatment plants spend more than 40% of their operating costs on combating microbiological water pollution. Aqua Q developed AquaTrack, an optical real-time 24/7 early warning monitoring and sampling system for detection of microbial water contamination. AquaTrack is EU Environment Technology verified and provides immediately reliable information to plant management prior to contamination occurring, so they can act, prevent, and save costs.
Thank you, Ulla.
You're welcome.
Thank you. I give the floor to the new members to ask you a few questions. Thank you.
First of all, I'll start. Congratulations with the product. I think it's a very nice movie as well. Promotes a lot the application of it. What I would like to ask is if you could dig a bit deeper into the technological part, as in how does the sampling mechanism differ from other typical automatic sampling systems, and the fingerprint analysis you have. Is it based on flow cytometry? Is it based on DNA analysis? And how does that differ from other systems on the market?
Okay, so our system is an early warning system. We can't say that it's an E. coli or coliform coming swimming. It's an early warning system. And the most important thing is that we take a water sample when there is a contamination. We don't take random sampling or collective sampling, because that doesn't say a thing. You have to have the correct water to be analyzed. And that is our innovation. And we also have this fingerprint of the water when there is no contamination. So when the fingerprint is when the water contamination is above that fingerprint, it automatically takes a water sample, send an alarm to the operator, and then you can analyze it in time. But of course, you can't wait for the analyze to come. It takes several days. Then we can also put in our polishing system, so you can remove the contaminants and people can get water before they get to the analyzing result, because then the water is without contamination.
Thank you.
Thank you. I would just like to follow up on Tom's question regarding this. So you said that you take samples only when there is contamination present. What is the threshold? How do you define what is contaminated? Is it quantity based, or how do you define the contaminant type? For example, excuse me, just to
sorry.
to provide a little bit of my question for the problem holder, as I understood, they would need to use to detect these residuals from the effluent treatment. And where do you fit in this story with the early warning signs?
Because as I say, we only take a water sample because we put up a fingerprint. We analyze the water quality, and then we see that we put the fingerprint on that water, and we have also so we can see that because we monitor 24/7 every minute, and then we can see when the water quality is deteriorating, and then we can take a water sample to be analyzed. But don't wait for it. We can clean it before. So I don't know if I'm clear enough.
Okay.
And that is our innovation, and it's patented. So, I mean, it's sampling, it's early warning, sampling, and removal, and that is for the whole patent.
Thank you.
So thank you very much. Also follow up to Viesna. So, and if you recognize there is a fingerprint of some microbiological pathogen, then you induce ozone in a defined quantity. And you can use this water for drinking, or how is the further use then?
Of course, you can use it for drinking, but then it has to be more clean. But in Singapore, they drink the treated wastewater when it's cleaned. But we are using it for irrigation purpose, or in Sweden, we have a system where the wastewater treatment plant use that water for technical water. So it can be different purposes. I mean, you can use it for irrigation, as I said, or cleaning cars, or so you can set the different quality of the water. I mean, if you want to use it for flushing the toilet, you don't need to have such a good quality. So you have to know the quality before you use it. And as I said, it's an early warning system. So you know, it's like they warn for earthquakes by this thundering, and this is an early warning system for water quality. So you don't need, I mean, if you today you take random sampling or collective sampling, but it's too late. People will get sick before you get the analyze. You have to know it in real time, online, and that is also our patented system. Our software also.
Thank you.
I don't know if I have time for last question.
All of you asked already one question?
No, if I can do a last
Okay,
question.
yeah, try to start because we are a bit late already.
Okay,
so yeah.
That's clear. Thank you. So I kind of can't. Sorry.
Go ahead and ask the question.
Okay, sorry. I understood. But so about the go-to-market strategy. So you look for like a licensing agreement of your technology. How far have you work so far with these licensing agreements with other partners so far? Yeah, how is this process now?
We're looking for, of course, like I said, partner and also licensing, and also for piloting the system. But actually, just today, when we are in India, we have just signed a collaboration agreement with an Indian company to be able to promote it in India. And of course, we like to do that in Europe too. So it's easier for us to travel to Europe than to travel to India. So we're looking for a cooperation partner to be able to take this further, and for licensing also.
Thank you, everyone. Let's continue with the next video, which is from Sophie Filtration. So thank you so much.
Thank you.
Hello, and greetings from Finland, the land of saunas, Santa Claus, and Sophie Filtration. My name is Ville Haakala, CTO and co-founder of the company, and for the next few minutes, I'll give you a general overview on what we do. We promote water reuse for water efficiency and saving the planet's fresh water for future generations. This is very important, that's our mission. For that, we have developed advanced water treatment technology to treat large streams of water containing very fine particle contaminants that are difficult to treat with traditional methods. Simply put, our technology removes the fine particles from cloudy liquids to create a clean liquid. Typically, the industrial client's motivation is to treat the discharge water to reduce the environmental impact from the plant and to meet the environmental regulator set limit. But more and more, the plants are looking at ways for reusing their water to enhance the water efficiency and to reduce the demand of new water for the plant. Also, in some instances, the fine solid material is actually valuable and can be captured from wastewater stream with our technology and returned to the process for higher product recovery. On the left-hand side, you see the key features that makes our technology unique. First, we use a high-velocity cross-flow filtration method without any moving parts inside to get high capacity in a compact size. Second, we use very fine filter elements that can go down to below 1 micron filtration rating. These filters are very robust stainless steel structure that can last for years. Thirdly, we have the powerful self-cleaning methods, an integrated ultrasonic resonator that releases the particles that get stuck in the filter element, followed by an air-assisted back pulse that flushes away the particles. With these methods, the system is continuously operating without any operator attention required, without need for chemicals to clean, no disposable filter changes required, and the system can be remotely monitored and controlled. This is an example case. We delivered a full project to municipal waste-to-energy plant that was producing condensed wastewater stream for discharge. We provided the client Sophie filters for total suspended solids removal, followed by high-temperature reverse osmosis system. This way, the client would save both water and energy by returning the hot water back as makeup water to their plant. In this case, the payback time was very lucrative. Getting started is super easy. First, client can send us a water sample to be tested in one of our application testing facilities, either in Finland or Texas, United States, depending on where the client is located. That gives a general filterability result, either a go or a no-go. If it's a go, we have a number of different sized mobile equipment that we can send to field trials together with one of our experts. Here you see some of our references. We've been mostly working with power plants, mining and construction, and steel mills, but have done a number of cases in different industries. Happy to discuss more of your application. Please do not hesitate to contact us to the contact information below. Thank you.
If I may start, thank you very much, Wille, for the nice presentation. Could you tell me something more about your team? Who is in the background? With whom are you working? And maybe your expertise?
Yeah, so all the co-founders come from mining and minerals processing. So we built the system to be very robust, that can operate in a remote location in a very hard conditions. So that was the basis of the system. And so it's a heavy industry, bias from our side. All the system is built from stainless steel. And we've built sort of a very advanced water treatment features for our system. So we used computational fluid dynamics. So there's a little bit of a technical university background. We used that to simulate how the crossflow and the whole system operates. And then we brought these very fine filter meshes, which are robust sintered stainless steels. And with them, we can go to lower micron ratings than any other mechanically self-cleaning filter can operate. And then the ultrasonic system as the dot on the I, so as the cherry on the top of the cake. So a mining minerals processing background. Now, of course, we have all the back office and all that kind of stuff. So, but most of our engineers are sitting in Finland, and we have basically a few guys in the United States where we have a 100% owned daughter company.
Thank you. If I may follow up, I'm very interested in these filters you mentioned that filter particles lower than 1 micron, which is fascinating. And I was wondering, as I work sometimes with the nano and microplastics in the freshwater systems, could you also capture nanoparticles of plastic, or have you ever encountered them? Do you plan to focus on that also?
There is preliminary testing we've done for a municipal wastewater treatment plant in one of the municipalities in Finland. And it became obvious that actually detecting those microplastics is the issue. So the laboratory capabilities wasn't there, and it's been developed. Maybe that exists, and maybe you know of that in Europe, but we didn't have it at the time. So while we think we can do that, and there is actually a plastics case where we have an installation, it's an LDPE plant, it's a polymers plant, to define how much microplastics there is, it's still yet to be shown. I don't see a reason why it shouldn't, unless it's actually nano-sized. So if it's actually nano-sized, then it's likely gonna pass through the filter. But the microplastics, whatever is that size, I mean, it's some microns probably, that's probably okay for us.
Mm-hmm. Thank you.
Thanks.
Also from my side, always nice to see new filtration technologies. My question has partly been answered by the fact that it can go to lower micron ranges. But compared to other pre-filtrations like disc filters and drum filters, etc., how do you compare in terms of costs?
Yeah, with the disc filters and drums, we go to the lower micron rating. So we let's say in upstream oil and gas, we are typically against back filters or cartridge filters. So then it becomes the issue of what's the disposal cost and change cost of those. And then there we are very competitive. Regarding the disc filters, it would remain to be seen, to be honest. Higher flow rates, municipal side, it's likely more disc filters than Sophie filters. When it comes to the industrial side, can shift to Sophies. We have a couple of cases in steel mills for cooling water recycle loops, where they use these sand filters that are house size, so huge structures. And we have a normal person-sized system operating the same flow rate with the better effluent quality. So there, the compactness is actually our key advantage. So it depends really on which application we are talking about.
Well, thank you. Just to finish the round of comments and questions, Well, I will not do a question, it's just a comment, because as you have seen, we have made questions on expertise, on how to compare your technology with others. That are parts of the evaluation that we need to do. And I think in your presentation, which was really good, but it was really focused on sales or technology and not focused on all the aspects that we need to evaluate. So maybe for the next time, take a bit of time to readapt a bit your presentation, trying to focus on all the aspects we need to evaluate. So after you have answered very well, but for the next time, for the pitch, maybe think on that, okay? Just
sure. I appreciate the feedback.
Okay, thank you everyone for your questions and answers. We will continue with the next company. Thank you, Villa, and thank you everyone. Bye.
Thanks.
Hi, on behalf of Aqua Radar's team, it's my pleasure being here today. We all face important water challenges: quantity, quality, and climate crisis. In order to solve them, we stand by this known quote by Lord Kelvin: only what gets measured can be managed and improved. That's why we've created Aqua Radar, an early warning system for a sustainable water management. In addition, we've got water engineering expertise, from design all the way to execution. Special mention to water treatment plants and wastewater treatment plants. Our third why is helping to achieve sustainable development from water. Without water, there is no viable environmental, social, or economic activity. We are glad to discover that ENCE's Biofactory in Pontevedra, Spain, is today a world leader in environmental management in their sector. Nevertheless, they've identified several water challenges in this plant: reduction of water consumption, reuse of this water, even the municipal treatment plant, increasing the control of the processes, and ensuring high performance of them. We have an overview of the whole process, from catchment to the effluent, a great opportunity to walk from data towards actionable knowledge. In order to do so, we need to get the insights of three pillars: processes, technology, and people. For instance, around processes, any issue of temperature in water circuit, any interest on certifications, for instance, of the quality of the effluent with blockchain. Technology, is it ensure the high performance of DAF? What's the digital maturity of the plant? Any sensor in real time put in place? And people, soft skills, but key, in order to create and maintain a culture of reduction of water consumption. With all the aforementioned, we propose to co-design the optimal digital twin of ENCE's industrial wastewater treatment plant, taking into account processes, people, and technology, and even waterside management. Why not? And we have a plan to be co-designed and developed with ENCE. Our track record demonstrates that we work hard to achieve the toughest goals. Aqua Radar team is looking forward to having the opportunity to walk this ambitious water journey with ENCE. Let's water it.
Shall I kick off? Also here, again, I think every initiative is nice to see here as well. It's a bit different from hardware now to software, which is very interesting to see because we can optimize hardware with software for sure. How would you compare your system, your approach to other CFD modeling companies that create digital twins?
Well, first of all, we don't. Sorry, can you hear me?
Yeah. Yes.
Okay. First of all, we don't only offer just a closed or a product. We have a modular solution. So as we mentioned in the presentation, first of all, we suggest clients to analyze and monitor all the data. Many times they don't have all the data needed in order to design the best solutions. So we use tech with purpose in order to sustainable management of this precious resource that is water. So usually the enter is via a sensor or any kind of data integration into the system, getting the knowledge of the stands where they are. And from there, we co-design the best optimal solution for their case. And in this case, in this presentation, we focused on ANSYS. Of course, we have a broader offering, but just a matter of time. So ANSYS challenge is really interesting because they have advanced a lot regarding the wastewater treatment plants, the containerized solutions. But we think there's room and place in order to improve, especially with data. But anyway, it depends on any case. We have some nice results. For instance, a bottler is tier 1 worldwide. And the project we proposed them, it had a return on investment in the first month. Maybe we are really cheap, so could be always also a return on investment in 2 months, but anyway, it was in 1. And the impact, it was a secure water for 23 million users. So this is the kind of how we approach projects. We focus on their needs, on the resources, and the target they are heading to, and we co-design the solution with them. Sorry.
Okay, if I may. Jorge, thank you very much. So considering your product is, as I see, very much digital focused, and actually like with a variety of technologies also. I like the approach of also considering people within this process. How are you integrating them? Is there like a capacity building or a prescriptive? How do you work? How do you integrate them in your approach?
I think, sorry, just in order to understand you well, do you refer to the client or our team?
For the client.
For the client. Well, this is the magic is connecting with the right people and trying to involve them and work along them. That's why we are modular based, because every case is different. Even the same company, each plant usually has different challenges. So we try to show them that the optimal solution usually is not only technology based, but people and the culture of that plant is key. So we try to involve all the stakeholders. And in this case, a leader, Ascente, we would suggest them to consider also the outskirts of the plant. So the watershed management probably could be a leader approach. So in this case, as we just give a brief drop of a suggestion, the watershed management for a leader maybe is the proper approach, but we would like to co-design with them if it's proper and just work along them.
Thank you.
if I may, add a question. So I've seen one of the slides of your presentation about, being accepted or profiting some acceleration programs such as Bind 4.0. How have you experienced some modification or your business model through accessing this kind of acceleration program? So more from service to product base, or trying to have more recurrent incomes, revenues, instead of trying to have like a service type of company. So have you experienced this kind of thinking during this process? Or can you tell us a bit of your experience?
Great question. We learn every day. So of course, this kind of programs help us a lot. We are validating almost every day. And these kind of acceleration programs give us new clues every time. And especially we don't apply to anything in the field. We try to select a lot every year, at most just 1 or 2 programs. And in case that the demand is in this kind of acceleration programs. So Buying 4.0 was one level for us. And that was the entry point for that Tier 1 global company. This factory had an income of 900 million euros. So it was the great opportunity. And like this one, probably, we would like to be. But we learn every day, yeah. And of course, we are searching for and working hard to get a regular income basis, but that depends on every client. We are proposing and suggesting renting as an example in order to update the technology hardware, because in 2 years, usually it gets outdated. So we suggest the hardware and the service and the update of it, but depends on every client. But we are looking for that, yeah, for sure.
Thank you, Jorge. I just have a petite question for the end. I'm not so familiar with digital twins, but I was just wondering, on the track of the thing that you said, does the digital twins, this technology adoption, does it leave out small businesses out of the equation due to the costs?
Not really. I'm just remembering that we don't usually focus on technology. We try to understand very well the needs of the client we have in front and work along them. As far as we get deep insight of their needs and the resources, we suggest a short list of solutions. Regarding digital twin, now there is a hype around them. We go with open source solutions, no licenses. You can access from every kind of device, and it's open. So in case they want to enhance it or incorporate new modules, it's really easy. And it's just, for instance, yesterday, one of the main cities in Spain has hired us for a digital twin in order to monitor and manage a city park. And well, one of the keys was that this open model is being it's been really satisfying for them. So it's accessible for almost every medium-sized company. Usually, technology is not the problem. It's culture and the openness to innovate. So in this case, this is a minor contract. So every medium and even a small company could have a digital twin for their infrastructure. But we don't sell digital twins. We try to dive into their needs, and in case there is a case there, then we can suggest as this case in ENSES, we think it can be really useful. But technology is transparent. We are agnostics. We don't sell any brand. We try to offer what we think is more useful and sustainable in time.
Thank you. That makes it much clearer now. Thank you.
Thank you.
Thank you so much, Jorge, and the jury members. We need to continue with the next solution provider as we are running a bit late. So I would like to ask you to be kind of concise in your questions and answers, because otherwise we won't have the same chances. So thank you. Let's continue with Dinak, with Maria. Thank you.
Hello, my name is Maria. Today I'm here to share with you the Dinak project. At Dinak, we are able to create water even when water is not available. According to UN, by 2025, more than half of the population will be living in water-stressed areas. So our mission is to provide with drinking water at a low cost and with sustainable solution based on the technology. And this technology is the atmospheric water generation. Basically, we replicate the process of rain, so we are able to condense the humidity that is present in the air and to transform it in liquid water, high quality drinking water. To do so, we just need a source of energy and, of course, the air. With this technology, we can offer some benefits, yes. First, the quality of the water. We are able to reach a high level of quality, equal or superior to bottled water. We offer the highest efficiency in the market if we compare with other manufacturers of this kind of technology. We offer a sustainable solution because we don't exploit natural resources and because we don't generate any kind of waste. No plastic, no wastewater, no salt. And also we offer a plug and drip system, so you don't need any kind of installation or civil works. Of course, our technology and our generators has been tested and certified, and they include an IoT system to be able to monitor them in remote. This technology has many applications. At the end, you need water in many different sectors. Basically, we have decided to focus on commercial to remove these traditional water dispensers with bottled water. Also in industrial, specifically in remote locations where logistics is a challenge, where they need an off-grid solution as the infrastructure is not available. Also for emergency relief, natural disaster, humanitarian aid, or in a similar situation. And we are also starting to explore the agriculture, specifically with hydroponic or aeroponics. Also, I would like to share with you an example. For example, we have this hotel in Mykonos. They are using at the moment bottled water with a cost of 30 cents. And we are able to offer an alternative with our technology where they can produce the water with a price of 5 cents of euro. If they connect it to the traditional electrical network. If they go for solar panels, they are producing water, at no cost. So you are completely autonomous in water and energy production. Of course, you are also avoiding logistic, waste management, etc. If you compare, we can compare this technology with another water treatment alternative. You can see here some of the advantages and disadvantages, but I would like to focus in something. All these technologies need a previous source of water. With atmospheric water generation, no water is needed. We are able to be independent because we are able to create our own water. Here you can see also a little bit of the situation of the market and where we position ourselves. Basically, we are offering a high quality product and we are offering also a competitive price. And also here you can see some of the people that are part of Dinak, and we are committed to provide the best technology to the water, to solve the water challenge. Thank you very much for your time. And of course, we are more than interested to receive your case to be able to offer an alternative for all these people that are suffering water shortage and water problem. Thank you very much. Hello? Can you hear me?
Hi, Maria. Yes, I can hear you. Creating water from thin air, very nice.
Yes, it is.
Is there a chance or is there a danger that certain volatile organic compounds or other pollutants co-condense with the water?
At the end, we have designed a water treatment. The first stage of this water treatment is the air filtration. So we filter the air before to condensate the water, humidity before to condensate the water, and then we incorporate inside of each generator a small water treatment, including filtration, mineralization, UV lamp to sterilize the water in order to offer a high quality drinking water, not only drinkable.
Thank you.
Thank you.
Thank you, Maria. Really short question because we don't have much time. I was just wondering, since this is like cutting edge technology, does the box, the generator, is it called generator? Does it require still quite a lot of energy consumption?
Depending on the model, but our main effort when we are developing the technology is to reduce this cost per liter. At the moment, the lowest generator, the lower energy consumption that we have reached in the generator in one of the new models is 0.21 kilowatts hour per liter. So the cost of the water depends on the cost of the energy. But this is the lower amount of energy that we can perform at this moment.
Mm-hmm. Thank you.
But we are quite efficient. At the end, we always make the numbers before to enter into a project to check the viability. This is related to energy consumption.
Of course.
Well, may I do a little question and a little comment? When you show the slide on price and quality, you show that you're still quite expensive, right? So it's plus it's
if we compare, if we compare ourselves with our competitors, we are on the top in pricing, but we are even more on the top in quality. Okay, I'm talking about the price of the generator. At the end, most of our competitors are from China. They make like dehumidifiers, so they are quite cheap, but they cannot offer the level of efficiency that we reach. That's the thing.
Okay. And you show the case on Greece on the other hotel, but have you already start selling, because you show this as a potential case, but how is your sales so far? Can you explain a bit?
Yes, we are already commercializing the unit. We are present in more than 60 countries with bigger or small projects, depending on the country. I pick up Mykonos because most of our market is not in Europe. At the end, we are lucky. We have a very good infrastructure in water. So most of our projects are in Colombia, Southeast Asia, and Central America, South America, North of Africa. We are not very, very present in Europe yet, because at the end we are increasing these water problems also in Europe. So that's why I pick up this not a theoretical case. We have something similar in Ibiza, for example, in Spain.
With all of you ask your questions? Okay, perfect. Thank you so much. Thank you, Maria.
Thank you.
Let's continue with the next company, Demand Side Instruments, with Rudy.
Hi everyone, I'm pleased to talk to you about the solution Aqua Radar that we have built at Demand Side Instrument, which makes Syrian agriculture possible. This solution will target farmers and allow them to monitor their crops, save time and performance, and learn serenity. It's basically composed of sensors and actuators, so we are using IoT technologies, and provide features such as irrigation management, real-time alert system, and also complete mobile and web application. Our innovation has been rewarded in different challenges in 2014 and 2016. The goal of this solution is to provide an autonomous and intelligent irrigation management system, focusing on minimizing water and energy consumption. In order to achieve that, we are making irrigation decisions as close as possible to the valve, so directly on the gateway itself. We are minimizing cloud, bridge, and sensor data transfer. We are providing irrigation in case of connectivity loss, which is a big advantage. And we are saving water while maintaining the same yield in limiting evapotranspiration and maintaining the plant at the limit of water stress. The solution is composed of different sensors, like connected weather stations, soil sensors, and connected controllable valves. All the sensors are connected to our bridge, which is solar powered. The data are sent to the cloud when it's required, and the mobile application allows the farmer to visualize them, and the application is already available on the stores. The problem we are trying to solve is to reduce water usage for agriculture, because we are consuming 4 billion cubic meters of water per year, and 70% of this consumption is used for agriculture. Given the fact that agriculture production must increase by 70% in the next coming year, we just can't afford to use as much water and find efficient solutions. So the solution we are offering here is going to significantly increase farmers' knowledge on their crop and fields, allow them to control remotely the irrigation system to save water, and we are still working on introducing new sensors, and we are working, for example, on connected fight against pests. The market of connected agriculture is worth $3 billion today, and is going to grow to $9 billion in 2030. So the most prominent markets are Asian Pacific, European, and North American. Right now, we are deploying the solution in France and Reunion Island, and we are targeting next Italy and Spain. When it comes to competition, there is a lot of players on this field. And the big advantage that we have is that we are bringing intelligence closer to the valve, which allows us to cover geographic areas with limited connection and work even if the connection is not reliable. The business model is based on direct sales, first of all. So we're going to sell the sensors, the gateways, and the mobile application. We're also going to provide extra services like agronomic advices, thanks to the data we are going to gather on the field. And this is going to be managed by a remote agri-specialist. And we are going to highlight sector of excellence and promote the know-how of the farmer. The team is composed of the CEO, Frederic, which is an expert in radio frequency and electronics, myself, the CTO, an experienced software developer. The CFO is an expert in innovation and project founding. Abu is our application developer team leader, and Maysam is our AI and machine learning expert. Thank you for your attention.
Thank you very much.
Hi, everyone.
I can start with a question. You mentioned that you are going to focus on Italy and Spain. These are, as we know, hotspots for climate change at the moment, and there are going to be quite drastic changes, and they are already happening in water scarcity and desertification and such things. I was just wondering if you provide, you said that you provide advice for the farmers. Could this advice also implement their data into building some, for example, simple climate models that could help them in long-term planning? Because everything is going to be changed in 10 to 15 years.
Yeah, exactly. This is the plan, indeed, because we believe that to react to climate changes and all those issues we are seeing right now, we need data, and we need those data to build some models and adapt the use of water depending on the field and the geographical area. So this is exactly what IoT can help for today. And thanks to this data, we believe that we will be able to understand in a better way how to use this water in a sustainable way.
Thank you.
I would like to ask the same question I asked the first contender. According to you, what would be the competitive advantage of sensor-based optimization of irrigation and fertilization compared to satellite imagery?
There is some difference because, yes, the big advantage of sensors is that you have more precise data on very local and precise areas. But
Hi,
we
Rudy.
believe that
Thank you very much. Very sophisticated. I wonder if you have some open
okay,
source approaches included in your.
there might be some lags. Maybe I was trying to answer the previous question. So I will try to continue. So yes, I think satellite data are complementary to the data we are gathering thanks to IoT. In the next versions, we would like
There might
to
be some delay.
combine those data and use them both to consolidate the models you can build with satellite imageries. But the IoT data will help to have more precise answers and validate, those models we can build with satellite imagery.
Yes, well, I had also the same question. So maybe for improving your pitch next time, you can include like a sort of what is your competitive advantage compared to only satellite-based company? Because I guess that including all these IoT and all these sensors, it costs much more to implement comparing to only data-based platform. So maybe you could add a slide so comparing and these two technology, or if you are planning to combining them, so really the cost and really seeing why your approach is better than the others. So it would be useful, I think, to convince customers and also investors.
Understand. Thank you. And something to highlight also is the fact that if you just have satellite data, you can't act on your field. So this is what we choose to start with IoT, so we can act on managing the water.
Thank you, Rudy. I think Andres is having some problems with the delay in his computer, so I think he wants to formulate a question around if is there an open source approach to this sharing of software?
Is there an open source approach?
Or maybe related.
Yeah, when it comes to IoT, there is some standards that are coming right now on the communication protocol part and also on the data sharing. This is something that we are looking after, and for now we don't have any standard that is used by all the competitors, but it's something that is we start to have some good thinking about that, and this is something we are trying to follow.
Thank you very much. Thank you, everyone.
You're welcome.
Okay, so I would like to give the floor to the final company, Inno-Sense, from Ricardo, that will be presenting his video now. Thank you.
Did you know that paper industry is one of the industries that demands the most water? There are data in the literature that show an average consumption of 54 cubic meters of water to produce just 1 ton of paper. It's also a complex industry that uses many potentially polluting treatments. And in addition, the legislation is quite tough, requiring very low level of contaminants, especially if the water goes directly into aquatic environments. ENCE has been improving its water receiving processes for years, where it's evaluating new processes, looking for reduction of organic matter, reduction of nitrates, and phosphorus elimination. And we can present a concrete, defined proposal. The proposed solution is our Inno-Eka system, which is unique, combining the efficiency of the electrocoagulation to precipitate organic matter, suspensed solid, and phosphorus with the efficacy of the electrooxidation to eliminate complex elements such as ammonia, fats, heavy metals, polyphenols, efficiency and effectiveness all in one system. We can show results in liquids as complicated as pig slurry. Over 90% of reduction of organic matter and suspension solid, over 80% of the elimination of nitrogen, chiadal, and ammonia, nearly 100% elimination of phosphorus, but it's absolutely relevant that no external coagulants are required, no external oxidants are required, only cheap electrodes and electricity. We have chosen two different proposals in different factories. For Navia factory, aluminum electrodes. For Pontevedra factory, magnesium electrodes. In Navia factory, aluminum electrodes allow us to achieve almost the target reduction of organic matter and suspension solid easily. And in Pontevedra, because of the decoagulation, the phosphorus reduction will be around 100%, but in addition, this is absolutely groundbreaking. The reduction of nitrates by intercoagulation has been shown in several publications to be around 90% with magnesium electrodes. Our proposal is divided in two phases due to the different concentration of organic matter between our waters and the ENCE waters. The phase 1, we will implement a base system in each of the plants, and the phase 2, once the results are achieved, depending on the capacity of the water that can be treated, we will be able to evaluate the scalability. But always with 3 added advantages. All in one system, easily reliable, being water with conductivity, the electrical consumption is drastically reduced, and with minimum space requirements. And it gives us access to a new blue market, the nitrate removal market, that because there are no effective solutions up to now, all the solutions have moderate results. And as you can see, it's a problem in the whole Europe. And we will be able to expand our strategic scenarios, and just a little image of our leading team that is made from expert professionals in our respective fields. And thank you very much.
Ricardo, thank you very much for the presentation. Question I would have is the electrocoagulation technology that you adopt compared to other electrocoagulation suppliers. How do you compare to in the market?
Well, talking about electrocoagulation, what other electrocoagulation layers are you talking about?
Well, I know some others. There are some who investigate electrocoagulation. I know a startup here in Belgium, for example, who is also working on it. Many of them are trying to enter the market. And one of the main disadvantages they always mention is the cost compared to the conventional technologies that are adopted. And I just wanted to see how you are tackling that compared to other startups and scale-up.
Okay. This project has, the origin of this project is because we won in 2014 the SME initiative, because with this system in the pH slurry, because the unique combination with electrocoagulation plus electrooxidation, with cheaper materials, with no coagulants, and with no other resources than read it. And in this sense, if you want to precipitate the solid suspension, you can use only electrocoagulation, but if you want to eliminate some pollutants on some other situations, you can activate the electrooxidation at the level that you require. And they think that is absolutely novel in the market.
Thank you.
You're welcome.
Well, I can continue. So very good presentation on how to focus on the problem of the project holder. But we go very fast on the last slide on market and on go-to-market strategy. So I just hear that you want an SM instrument call. No, you just mentioned some on helping innovative, disruptive technology to go to market. So how far have you reach the steps on the go-to-market strategy that you planned or you have planned on the last years. It's interesting to very innovative companies how can they sell their technology.
Okay, thank you. Well, honestly, the last slide was the team, but it hasn't been shown. So as I think we are an expert team because that they have been working several years in our field, but it's not relevant. But the last slide that you have seen or that everybody has seen, that's about the market. Well, we are talking about an industrial market, and in our current situation, everybody wants to know that our system works absolutely well in their kind of water. So we need to put a pilot plant in any other market that we have to win, because okay, everybody can assume that our system is going to be very effective, but they need to see in the field. This is the case for ENCE, and it's logical because it will be the first system that would be implanted in the pulp and wood market, let's say. Okay, so in this moment we are leading agreements with other companies to put the first pilot plant in every other sectors, and then we will grow or we will expand alone or in a joint venture with this company or in a license with this company. We are absolutely open in these kind of scenarios. Any other question?
I think we lost Andres, so thank you so much, Ricardo. I think that was a great overview, and with this we complete the series videos. Thank you so much to everyone that have been participating in this. Right now, I would like to take a short break. We don't have much time since we are with a bit delay, so let's take a 5-minute break, and we will be back in 5 minutes with panel discussion with great water experts, which I will communicate when we are back. So I'll see you in a bit. Thank you, everyone. Hello, everyone. We are back. It's been a short break, but we have a huge roundtable coming up right now. I'm very pleased to have here Abby from H2O News. She's a journalist. Hello, Abby. Nice to have you here. So Abby will be moderating our session today with Hassan and David. I would like to give the floor directly to you, Abby, so you can actually introduce yourselves and bring in the discussion.
Absolutely. Thank you, Patricia. Welcome to this roundtable. My name is Abby Davey. I am the co-founder of H2O Global News, and as mentioned by Patricia, I'll be moderating today's session, which is recycled water the key to solving water scarcity? Our panelists, David and Hassan, they will be sharing their points of views, but feel free to ask questions and I will try to get to them at the end of the session. But without further ado, I'm going to hand over to David and Hassan to introduce themselves. David, take it away.
Hi, good morning, everybody. My name is David Smith. I'm the director of WMB, which is Water, Environment and Business for Development. We are a consulting company that is based here in Barcelona, and I myself have a long history and background in the water industry, specifically through Thames Water in the UK, where I was a plant manager before starting WMB, and then obviously completing my PhD this year. So I'm really looking forward to sharing some insights and answering some of these questions that Abby will pose to us, discussing these things with Hassan. So I'm happy to be here. Thank you for the invitation.
And Hassan, please introduce yourself.
Yeah, hi everyone. It's a great pleasure for me being with you today to talk about one of the important topics for the challenges that we have facing today in our world is mainly on wastewater and how we really deal with it. So I'm Dr. Hassan Abu Naga. I'm the vice chairman of the Middle East Water Forum and the researcher at Cologne University of Applied Sciences in Germany. I am also leading a my work is mainly focusing on water security issues, climate change, and sustainable development. For sure, I'm a civil engineer by profession, and I would be happy to give you some insights on the topic. Thank you.
Excellent. Well, David, I'm going to come to you first. What are some of the specific water challenges facing the manufacturing sector in Europe?
Yeah, thanks, Abby. I think it's a very astute question, especially now that we coming out of what was a very difficult session for us with the COVID-19 pandemic. The manufacturing sector across the whole of Europe suffered quite substantially during that period, and the output was dropped around about 8% across Europe. And that only started to increase again this last year. And now we're going into what will look like a fairly strong recession. So the manufacturing sector as such is struggling somewhat in sort of the global events that are happening. And one of those aspects, which is compounding some of their issues, is indeed water. And this is with regards to water availability, water quality. And so these are some of the main challenges that they are facing within the sector. As the water quality through pollution or through climate change effects starts to deteriorate, that basically means that different types of treatment systems will need to be implemented. Technologies and advanced technologies need to be implemented within each one of these manufacturing aspects. And that increases the cost at the end of the day for the manufacturing side. And then also on the other side, you've got legislation. Legislation starts to increase. You get stronger legislation, which is something that we've obviously needed for a long time. And that also then compounds these issues for the manufacturing sector, that they need to comply with these legislations and policies that are coming out across Europe, but then also aligning that to the individual countries that they are working within. So these are some of the major issues that they're facing, specifically in terms of water.
Wow. And Hassan, are you identifying similar challenges to this in the Middle East?
Yeah, it's the same challenges, but with more acute and the complexity of the systems and the conditions that we have. The Arab region or the Middle East and North Africa is the most water scarce region in the world. So we have a problem with water availability. And also one of the greatest challenges that we have, and it's also in many developing countries, that we're still counting on linear systems of use and dispose. And it's very crucial for us in the region, in a water scarce region like this, to shift from linear system of use and dispose to more circular economy model, and for sure using wastewater as an opportunity, not as a risk. And the challenges on this comes from mainly lack of access to sanitation. You would find 40% of our population in the Arab region don't have access to sanitation. And globally, also the challenge is really also alarming for us, because we have 4.2 billion people don't have access to safely managed sanitation. So before we talk about wastewater treatment and really working on technologies on this regard, we need really to focus on the people that they don't have access to the sanitation, and looking at all the water system, water supply and the sanitation as a one system. Yeah. Which for sure this was a major challenge or a major mistake that many development agencies and the governments that have been doing on differentiating between water supply and sanitation. That is why we see this the gap. In terms also of finance, there is also a major finance gap, where we need 4 to 6 times of the capital investment of today in order to meet the SDG 6 by 2030, and to really to achieve the SDG for sanitation, SDG 6.2. And this would be really the major challenge. Coupled with this, that many manufacturers, the manufacturing sector is really facing that challenge, or the fundamental challenge of doing more with less. And this is compounded by socioeconomic challenges, cultural challenges, governance challenges, all of this, contributing to have and also not having an enabling environment for the manufacturing sector to expand more and to unlock the potential of wastewater as really untapped resource in our region. Thank you.
So it's quite obvious from both of your statements that water reuse is now a priority for manufacturers. But I'm going to pose this question to both of you. What do you believe, and I'll start with you again, Hassan, to flow. What do you believe the barriers to water reuse? What are the barriers for the manufacturers?
So the barriers is mainly about to have an enabling also environment with the legal framework and the governance in order to unlock their potential and their solutions in our region and in many also developing countries. But also manufacturers also have to do their work in the really different ways, with business models that really to fit to the purpose and to the priorities of the region. And this comes to see wastewater as an opportunity with 3 main components. It has water. With wastewater, it has water that could mitigate water scarcity. So if we wanted to make it to the level of the drinking water, so it means it would be very costly for them, and there is high level of technology that been used. It has also the nutrients, which can be used also to ensure food security in a region that really needs for food security. As I said, it has also the organic matter, which can be used for biogas and ensuring energy security. And these 3 main components the manufacturer has to really to work on it. And the major challenges that we see from manufacturer is not having a mindset of this fit for purpose. They have their own solution and they wanted to implement it in anywhere, and this doesn't work because there is no one size fits all solutions. But there is a great potential for implementing their solution, but they need to find and also the enabling environment. It also comes also to the legal also points of view. Some of the utilities or some governments limit also private sector to be engaged in wastewater, because it's really connected to the public health, and this is very crucial for also the human security or the national security of the country. So it's mainly manufacturers face the challenges mainly to change the mindsets of many decision makers on this topic, and this is very crucial for us. When it comes also to the technical issues, there is also a need to provide fit for purpose solutions and to see what are the priorities for this country or for this region. And this would be linked also to the ministries or the governments. They need to have a roadmap or a map for financing and for investment in wastewater, because we cannot say only one technology that could be used. You could make a map for their country, depending on where upstream and downstream for them, and define different solutions for them, and define the 3 solution components for them in terms of water, in terms of nutrients, in terms of the organic matter that they can use it for energy security. So having this diversity and have this mindset will really enable us in order to accelerate progress and also achieve water security and wastewater also treatment and reuse in our region. Thank you.
That's amazing. That would be great to break down those barriers. It's a big challenge, but we can do it together. And David, from your point of view, what are the barriers that these companies have to break down in Europe?
Yeah, thanks, Avi. And I think I'll follow on a little bit from what Hassan was mentioning. He picked up on some very, very important points. One of those was technology. And I would actually suggest that I believe, in my opinion, the technology barriers have largely been overcome. I think the technology exists and can treat complicated waters that we have seen in manufacturing that maybe wasn't available some 10 years ago. Largely, I would say that this barrier has now been overcome. Specifically, the manufacturing sector can have the major challenge of the legislative and policy sides of things. So to understand from their point of view what they can actually do. And this is where it becomes a little bit tricky for them. Over the last couple of years, this has been a completely unknown. Recently, there has been some more clarity in this area. The European Commission has published a new directive on water reuse and what exactly can and cannot be done, and what are the quality requirements and parameters that need to be met, and in what sectors indeed you can actually do this type of reuse and what type of reuse you can do. So the technology now exists. You're getting a legislative framework in which we can start to work. So where's the final barrier within all of this? And this is, I would carry on from what Hassan was mentioning in terms of acceptance. And this is really coming to the larger point of where the manufacturers are trying to get their products and processes into, and that is into the hands of the consumers. And it's the consumers at the moment that are struggling to accept that water treated to conditions that can be used within manufacturing is something that they can then eat, drink, or use as a product that comes from this manufacturing. And so there's been some really interesting examples that have come forward, some beers that have been made from water reuse, and they've actually marketed it as beers that have been made from treated wastewater. They pushing that very hard in terms of sustainable beer that is made and having taste testings, etc. And when it's beer as opposed to water that has been treated, all of a sudden there's a bigger interest, right? And coming forward from that. So it's these types of marketing and clever ideas that need to come from the manufacturer side. And the big players such as your Coca-Colas or your Pepsis, they need to really push this type of idea and this type of marketing forward, because once these bigger leaders within these industries start to take that lead, the rest will follow behind, and to see that indeed, if we market these products as using reused water, the consumers pick that up, the rest of the manufacturing sectors will follow in behind that.
Yeah, and consumers are less scared of the idea of water reuse, because if these big organizations are endorsing it. That's obviously a big green tick, which is the way how we perceive things. You touched upon the government's role being legislation to reuse. But what other role does the government play at the moment for you, David, in Europe in promoting water reuse, apart from legislation?
Yeah, no, it's a great point, because we do often think of the government in terms of, okay, policy, legislation, but the government at the end of the day is the voice of the people, right? And so they've been voted in from the citizens, so they're there to represent what the citizens are really looking for. If the government, in that sense, can have, from their point of view, the understanding that indeed we're sitting in a water crisis, in a climate crisis, that needs to have innovative solutions that are happening in the manufacturing sector, they can start to push forward these communication campaigns, these ideas of acceptance that need to come forward from these sectors. So not only providing the enabling environment, as Hassan was mentioning, providing that legislation, but speaking positively about these types of activities that are happening within the manufacturing sector, to allow for the citizens and their voices to be heard in terms of acceptance and accepting these types of solutions moving forward.
And Hassan, are you experiencing the same in the Middle East? What other roles would you say the government is playing in that region?
Yes. So the region is already, seeing wastewater as a really as a new source for them in the region, but it really needs from us a completely shifting on our way on how we manage water and wastewater, and how we finance water, how we collaborate with each other, how also we design our policies to be more integrated. Because if we are dealing with wastewater, it's interconnected with everything around us, and it needs to be addressed in more holistic way. And this is meaning by dealing with wastewater as a really a matter of really security, and also for opportunity for new entrepreneurs to be engaged in it. You would find when I was mentioning the enabling environment, it includes everything around us, from policies, from legislation, from also convincing and changing even the name of wastewater. We should call it the new water, or really something that could be able for the communities and for people. And this is very crucial, because when we just mention, especially also it comes from cultural and religion points of view, the acceptance, as also David was mentioned, is very crucial point when it comes to the implementation, because governments could have really a good plans and good strategies to implement wastewater, but acceptance would be opposed by whether with farmers or even with people and the households. So if you could tell them this could be also constrained, and this was happening also by law, that it is not feasible to make it from cultural and religion points of view. So we need to find the ways, to really convince decision makers and the communities, and having really starting this even in our education, from starting from childhood, from kindergarten, in order, to really have this mindset. And this is very crucial. Coming also to the same issue of financing of such projects, it's also crucial to understand that the status quo is not enough in order to really meet the wastewater treatment and technologies that we are working on. And we need innovation, and the innovation here not only from new technologies or technologies that we could deploy, but also new financing mechanisms. And this is mainly coming to diversify resources from really engaging the private sector with us, developing new also contracts like BOT, engaging different actors on it in order to make really the finance happening for it. Because you could have a good strategy, but this strategy is compounded also by constraints who will really take the role of it. And there is also many overlaps in wastewater between different ministries, who is taking the responsibility of what. And this is a governance problem, and also about who will take the lead in order also to finance such projects. So all in all, it will be coming not only is that addressing wastewater, it really comes from a collective action, not only from the government's view. It comes from the government, it comes from the community, but comes also from donors and also development banks, because they are the one who is also influencing the policies and also for many countries. And this is very crucial in order to bring all these stakeholders together and really to have a new mindset for wastewater and really dealing with it to cover both the management gap or the governance gap that we have, besides also the financial gap. And this is really needs, really a holistic approach when dealing with it, covering 4 main areas to work on it. This wastewater and the human well-being in relation with it, climate change and also the water-related hazards, the socio-economic part, and also the ecosystem, because the pollution that comes from wastewater infiltrated also to groundwater and to our environment. It really hurts our environment, and this is very crucial from also public health and also climate point of view.
Yeah.
Thank you.
Well, even just the point of renaming wastewater seems a very, it's a great idea. And like you said, it's not just the governments. But I'm going to bring it back to manufacturing, and I'm going to bring it back to technology now. And over to you, David. How can we make it easier for manufacturers to implement water reuse technologies?
Yeah, Abby, that's a very very difficult one to answer very clearly, because I imagine as you do, I as a consumer find it incredibly difficult to know exactly which product is sustainable, which one is really aligned to what they say they're aligned to, which one is not just greenwashing. And so I've often thought about this idea, just going shopping, to say, the product that I'm holding in my hand, is this aligned with my own values and my own ideas of what should be sustainable? So I think that the first point that we can help with the manufacturing sector in order to make it a little bit more sustainable, to use and reuse water in such a way that is a lot more equitable, is to inform ourselves, to make sure that we are sort of understanding exactly what it is when they're talking about the different types of labels that are on these products, what it means to be B Corp incorporated, what all of these aspects do in terms of water reuse for that particular product. Once we have that idea behind us and that information, I think down as citizens, it's for us to promote this idea. If we really want our world to be going in a more sustainable direction, it really is down to us as individuals to not only make those changes, to make those conscious decisions in what we are purchasing, but then also to promote this idea to friends and colleagues and in different types of conferences, etc., to say that that I, for one, don't buy this product because I know that they are totally against water reuse and they don't consider these aspects, etc. And then to really start to promote the idea that water reuse in the manufacturing sector not only is essential, but is completely safe. And I think that this is a point that will help the manufacturing sector to move more in towards the water reuse area.
And what promising examples have you seen of water reuse technologies in the work that you have done, David?
I think one of the more classic examples has come principally outside of Europe, and there's two main ones that I think a lot of us know about, and one that specifically has come from Namibia, where it's since the 1960s they've been doing direct potable reuse for urban reuse, and they've had absolutely zero failures. There's no outbreaks of any kind, and this has been forced upon them because they're more of a sort of a desert city. So this was something that they considered in the 1960s, and they went ahead with it. It was totally accepted by the entire population because they saw the necessity behind it. And there's never been an issue with this idea of direct potable reuse from wastewater. The other classic example that I think most of us know quite well is exactly what Hassan was alluding to, this idea of renaming water reuse, where they've done that in Singapore quite successfully. And instead of calling it water or reused water or recycled water, they're calling it new water, NU water. And so this is the idea that they have this concept where indeed this is not water that we've reused, regenerated, etc., but no, this is new water, and this is come into the consciousness of the people. They sell it in bottles, and in actual fact, it's now even become a place where people, specifically in the water sector, or at least have a consciousness of it, will go and visit their treatment works because it's become so well known that people actually want to grab a bottle of this new water and at least have it at home or drink it, to say, okay, what is it all about,
See, that's clever, making it a trend.
Exactly. And there's one final scenario which I think is a really good one, and it comes from Portugal, and it's Aguas de Tejo, which it's an urban water treatment company. And they've teamed up with a local brewery, and they've got their treated wastewater that goes to the brewery, which is perfectly safe for use in their processes. And they've marketed this beer as reused water that has made this beer. And every one of their conferences and their events that they have these beers. They're available for the public and everybody to try. And of course, this again promotes the idea of water reuse in manufacturing.
Amazing. And Hassan, I'm going to ask you the same question. If you can just a couple of minutes, give me an idea of what uses and what successful stories you can tell us about.
Yeah, I think there is two schools for dealing with this. One school is mainly working like the Singapore case study, when they also make the type of wastewater like from industry to make the treatment on the premises before it really discharges to the environment, and also have a really a resilient and also dynamic legislation for it. So it depends on the pollution that you put it in terms of quantity and quality, you will pay for it. So the more pollutants you put in the system, the more you pay. And this is very also innovative way in how to deal also with the financing point of view. The other school is mainly not having the treatment in the plants, and really have a legislation that all industries should or must have a treatment that really treat water at a level of the national standards or the WHO standards. And also the other school, which is really discharging all types of wastewater, industrial, drainage, agriculture, domestic wastewater into the ecosystem or the river or the water system, and then treating it. And here we have also many examples that we can see, and also in our region, from really mega projects. And these mega projects, like in Jordan with the Samra plant, which is also very also promising and innovative when it comes also to reclaiming and reusing water, wastewater that comes also from the Zarqa River basin, which and also that mainly comes from the Greater Amman and also Zarqa, which are really polluted, populated areas with many people in these areas. There are also mega projects that we can see in the past years in Egypt from Bahr al-Bakr treatment plant, which is really agriculture treatment plant, which also gives the opportunity for us in Egypt to reclaim 400,000 of headbands. and if a dam is 4,200 square meter. So this is really a huge project that we could say a mega project in the Middle East, is that we can all proud of it. But it really means also for us to have also decentralized systems, and here entrepreneurs and also small and medium-sized companies can work on them. There are also, we have also Mahsama wastewater treatment plant or agricultural drainage also treatment plant, which is also contributing to the same. It's mainly for the use for agriculture. But we need, from my point of view, I see that we need to have each country has a really an investment map on wastewater with different opportunities and different technologies and the different mechanism even for financing to find and to also to have really to really bridge the gap that we have now when it comes to sanitation and wastewater reuse.
Wonderful. So we do have some questions from the audience, but I do want to get one more very quick fire question to you guys. And that is, I'll start with you, David. Do you think that water recycling on its own can solve the manufacturers' water challenges? Do you think that is the only standalone that can fix the problem?
I think the very quick and easy answer here is no. I think there's obviously that's one component, and I think what we have struggled to do in the past is to see how one system affects the other. And so really what we need to be looking at is a holistic systemic approach. So we need to be looking at the human systems, the environmental systems, governance, culture. All of these aspects need to be integrated when we are looking at solving not only the water, but the climate effects that are challenging the manufacturing sector. So I would say not just the water, but more a systemic approach to the entire issue.
Hassan?
Yeah, I see. We can see now the answer when it comes to the competition between water users, between agriculture, between domestic uses. In most of the time, in many countries, you would find that more than 80% of their water is really going to agriculture sector. But now we see the competition is very intense between these two sectors. In the case of Jordan, you would find 50-50. 50 goes to the domestic users and 50 goes to agriculture. So this answers, it really makes for us that wastewater also has different water, and we cannot deal with it as a one water as we use. So we assume the wastewater that comes, it would be the same. So it would be the same in terms of quality. And this is what that we need to really make a strategy and a dynamic strategy, how we deal with wastewater with different qualities and how really we can use them in more effective way. And one thing is also I wanted to highlight also in this important meeting is mainly about the maintenance of the work that is doing also by manufacturer, because there are many innovative ideas and also I have seen of them today from our entrepreneurs, but really maintenance and really having this holistic approach to it, and also after the technology, because this is one of the major challenges that we see today in terms of the maintenance gap.
Amazing. And I'm going to go to the audience now. We have quite an interesting question from Cora. And we haven't touched upon this. So the question is, in the transition to a world where water reuse is common practice, what would be some of the key risks, such as water not being treated correctly? If I can go to you first, David.
Yeah, I think this is a risk that one has always had, and it's a risk that indeed sits in the urban water side as well. It's been there for many years. So when we talk about risks, I'm not too inclined to include quality in terms of that risk, because I believe that the technology that we have in place is able to deal with the quality issues that we potentially have. Of course, there's a risk of technology failure. This can always happen, but what has happened over the years is that there's normally more than one barrier that's in place. So even with the technology failure, you won't get any risk to society in terms of what you are producing. And you've got to think that a manufacturer will do absolutely everything that they can to make sure that the risk to population is practically zero, because any damage to a product is a damage to their branding, which is a damage to their future earnings. So this is something that they'll totally avoid. I would say the biggest risk that potentially manufacturing sector is facing at the moment is climate change. And so this is something that we all together can work on in making sure that whatever we do, whatever practices that we're implementing, we're taking the environment and the climate into consideration, because the manufacturers without water won't be able to manufacture anything.
Very true, very true. And to you, Hassan, do you have anything to add on to that?
Yes, I think wastewater is really sensitive issue. That is really, takes a serious also decisions from governments. And this is really needs from us is really to see what are the role and the accountability also for each partner and actors when it comes to implementation of such technologies, because once there is really a damage or really a risk come from wastewater or from the technology itself or with the water quality, it would destroy the credibility of the governments and the water utilities. And this, to get it back, it would take many years in order, and we have seen many examples on this. Another also point when it comes to really to have, I could say, like a mechanism for the governments in order to monitor wastewater in different places using the digital transformation, but also the challenges that we would be facing, like I could say the global pressures that we will face, the increasing demands from population growth and also influx of people to many countries that they don't use to have the same also demand. So you would find also a greater challenge of this, and also climate extremes, as David said, from also floods and droughts, all this impacting, the systems and really having a major risk. But the risk is in the transition, it should be like a ladder, and this ladder has to be going to really unlock the socioeconomic issues, the cultural issues, the acceptance for also it, the finance issues, the governance gap issues. All this has to be with a holistic, approach, and this is very crucial in order to have really an effective strategies to really reuse water and make it as a common practice for us.
Well, I just want to say thank you to you both, sharing your expertise. It's a really challenging subject. And like I know both of you have said multiple times in this, no size fits all. And it really does come down to how much everybody is invested in this change, in this transition. And I think the communication and inform the consumer is going to be key and critical. But thank you to you both. I hope everybody that is watching has enjoyed this roundtable, and I'm going to pass the gauntlet back on to Patricia.
Thank you, Abby. Thank you very much.
Thank you very much. That was very interesting. Thank you so much. Okay, so I think we had some people following on social media, and we have now all the solutions providers. The competition carries on, and we now have the evaluation as well from the jury members. So I think it's the time to give the floor to Matt, who's already here. And he will be presenting two of the winners from this competition and some of the reasons and discussions that emanated from the dialogue. Hopefully we can give the awards directly to the startups. Hello, Tom.
Hi. Hello. I think awarding these prizes was not an easy task. Each contender has shown that they have the required expertise and knowledge, both on their market and also on their added value of their product. It also goes beyond questioning that each solution is highly innovative and helps us tackle the water scarcity issues that we face. So the scores were very close. To give you an idea, the lowest ranking contender scored a total of 64% and the highest 79%. So that's very close to each other. And even closer was the difference between the second and the third place. That was only 0.01 point on a total of 5. So that's a very, very close call. And the differentiating factors that made these winners, or that helped us select the winners, was their higher potential to tackle water scarcity and the scaling up potential of their products. So without further ado, let's announce the winners. The second place goes to Dinak, that creates water from thin air. And the first place, I'll wait a bit.
Congratulations.
Thank you so much. Thank you so much. I have my team here looking at me. They were also checking in YouTube. Okay.
The first place then goes to demand-side instruments that optimize irrigation and fertilization using sensor-based data. Congratulations.
Congratulations. Do we have a representative from the company here? I don't think so. There's some people that didn't join to this. Hey, here we are. Yes.
Yeah, I'm here. Thank you very much.
Hey, here we are. Yes.
Yeah, I'm here. Thank you very much.
Congratulations, Rudy and the team. Thank you so much, Tom, for this comprehensive overview and for presenting the awards. So thank you. And let's continue with the prize given by the problem holder, ENCE, which will be presented by Silvia Cortiñas. Hi, Silvia.
Hi, hello. I would like to show our happiness with all these platform, all these activities we have developed with InnoWise. First of all, I would like to say thank you to all the options. We value very much the technological proposals all the startups have shown to us, and all of them have been very interesting for us. But at the end, even it's very complicated to choose one. It's the rule, so we need to choose, and we decide to select the option which has a better technological adaptation to the project in which we are involved or immersed. For this reason, we have selected to Sophie filtration.
Wow. Can you hear me?
Yeah.
Oh, thanks so much. Positive surprise, given all the good competition we had.
Congratulations. It's a pleasure. Your proposal, it's very interesting for us and our project. So we would like to continue in contact for the developing of that.
Very interesting. Very excited. Thank you.
Well, congratulations, Bill and Sophie Filtration. I think this is very good news, and a huge journey begins from here, working with ENCE, and I think this is a very good opportunity, and I think it's been very pleasant to hear from these innovations and solutions that are actually happening on the ground. So, yeah, I would like to give the floor to Blanca, maybe to give more details about the outcomes, next steps, and how the journey will continue. From my side, I just want to say thank you to everyone that has been involved today. We will continue tomorrow with another InnoWise Scale competition. Tomorrow will be on Climate Kick. So I will give you more details afterwards. Blanca, the floor is yours to give us a few words.
Thank you very much, and thank you all of you who attended, participated, and also the audience who was here today. I think it was very interesting to learn more on how to tackle water scarcity through specific examples and innovative solutions. All of them, as Tom has shared, are very, very strong. So the scoring that they had, all of them was very high and very tight. And I hope the winners are very happy and all of them happy with the program and the support they have received. So I hope and I invite everyone tomorrow to join the next, the second event with more pitches than in this case for a water utility company in Greece. And thank you all today. Thank you very much. Patricia, to you.
Thank you, Blanca, and congratulations again. We look forward to keep working on these promising solutions and bringing everyone together. So we'll see you tomorrow for those of you that can connect to discover more solutions. Thank you. Bye-bye. Have a good day.